What is up, guys? Today we're going to be doing some math. We're going to prove that the square root of 3 is irrational. To start off with, we're going to assume that the square root of 3 actually is rational. And we're going to show why that's not the case. So because the square root of 3 is rational, we can write it as the square root of 3 equals p over q, where p and q are both integers and co-rational. Co-rational is important because it means that they have no common factor. Keep that in mind as we move forward. We're going to use that at the end of the proof to, in fact, prove the whole thing. So, with that first equation, the square root of 3 is equal to p over q. We can move that forward to p equals the square root of 3 times q, and p squared equals 3q squared, which is equation 1. We'll refer back to that a few times. And from that, we can see that p squared over 3 is equal to q squared. So from this equation here, what we can see is that 3 divides p squared. And from that, we can assume, or it implies, that 3 also divides p, which means that 3 is a factor of p. That's very important to note. 3 is a factor of p. Excuse my leftiness. Moving on, so because 3 is a factor of p, we can write p is equal to 3c, where c is an integer, and that's because 3 is a factor of p. We can write it as that. So we're going to be plugging that into the original equation in just a moment. Let's clear this and that. Great. So we're going to be plugging it into the original equation. 3c squared is equal to 3q squared. So the 3c squared is in place of what used to be p. So 3c squared is equal to 3q squared equal to. From that, we can see that 9c squared is equal to 3q squared. From that, we see that 3c squared is equal to q squared. And from that, we see that c squared is equal to q squared over 3. So with q squared over 3, what we see is that q squared is divided by 3. And 3 also divides q because that just follows from the q squared. We see that 3 divides q. And just like we saw with p, that means that 3 is a factor of q. Now, recall from the beginning, we said that in order for that whole thing to be true, that p and q are co-rational. Co-rational means that they have no common factor. We've just shown that p and q are both have 3 as a common factor. That's a contradiction. So what we see is that when we assume that the square root of 3 is rational, and we extrapolate that out and write the equations based on that initial assumption, we see that p and q both have 3 as a factor, but the assumption is that they're co-rational as well, which means they can't have a common factor. That's a contradiction. And because of that contradiction, we see that 3, the square root of 3, is not rational. Because of that, it follows that the square root of 3 is irrational. And that is our proof.